Welcome to this Chicago Water Week Dutch event, and thanks Current for having a Dutch event at the Chicago Water Week. I want to kick it off to share a personal story, since it's a water event. And yesterday when I was preparing, I realized that, I'm always proud. It always makes me proud when I kick off an event where Dutch expertise is brought to a foreign audience. But when it comes to water, it becomes even more apparent when you don't live in the Netherlands anymore. Because when you're over there, you easily forget how much you live and deal with water issues on a daily basis, and how much is done to keep the water clean, to keep you safe from water, to let you have enough water, or to prevent it that you have a shortage of water. And it might be a surprise to people outside the Netherlands, but we do experience sometimes shortages of water. I used to bike around in The Hague when I lived there, and one of my standard routes went along the storm surge barrier at Hoek of Holland. It's called the Maasland barrier. It's got these two giant wings, so to speak, as large as as two Eiffel Towers that are flat, and they close when there's a really big storm. And it's an impressive sight when you bike past it. It pops up in a lot of presentations about the Netherlands to foreign audiences, and I always appreciate it when I see it. But then again, I bike past it, and there's they created an artificial hill a little bit further on, and I wanted to climb that and improve my time, and that was that. And now I live here in the US, and I have more appreciation of the water tech back home, and especially how well maintained and managed it is. I guess it is something special that you take for granted easily. So welcome again, and a big thank you to the Dutch water sector for making this possible, for Current for having us here on this event. And I also want to do a little shout out for my colleague James Purcell, who helped set this up. And I have to say, he's becoming an authority on water himself here in Chicago in the US Midwest. And also to Somotics, Held 24K and Acquaint, who will give you some insights on how water tech has become a hallmark of Dutch ingenuity. So I guess this reputation of Dutch ingenuity is partly based on how we deal with spatial issues, how we consider cost and efficiency, energy efficiencies, and how maintenance, as obvious as it seems, is key to long-term resiliency. So to close it off here, the Netherlands Consulate in Chicago, we cover the entire US Midwest, 13 states. It has the size of Western Europe and as big as Germany's economy, if you all put it together. And we are actively looking for opportunities to bring Dutch solutions to typical Midwest water issues, such as our urban flooding, wastewater management, rising lake levels, and aging infrastructure. Although aging infrastructure might be a nationwide problem, or maybe even a global problem. So yeah, finally, to prevent too much Dutch cockiness here, it's kind of a bad character trait of the Dutch. We are also interested in US solutions, of course, as we always want to learn from each other, and we want to collaborate and join forces with interested parties. So with that, I want to give the floor to Arjen, and I wish you all a very productive and insightful event. Thank you.
Thank you very much, Jeroen. Welcome, everybody. My name is Arjan Bramskamp. I'm the Regional Director for the Americas for the Netherlands Water Partnership. This event is a joint effort by the Water Alliance and NWP and the Consulate in Chicago. For us, it's really nice to be able to do these things. I mean, we have a lot of activities in the United States. As an organization, Netherlands Water Partnership, we represent the international interest for the Dutch water sector. That's global, so we have various focus areas, of which North America is one. The messaging is very different from what we do for the Netherlands Water Partnership in the American market than it is from some of the other areas where we work, for example, South America and Africa. Where, of course, there's a very different level of development, so that also completely changes the content and the nature of the interaction. So based on history and based on some of our shared interests and experiences, I'd like to believe that the US and the Netherlands have a lot in common, especially in terms of a professional approach. Of course, in terms of economic development, we are also both very established economies and also with a firm look across the borders, always to improve ourselves and to create new opportunities. So that's what we're here for. We do that through the variety of programming. None of this is going to look very surprising on the slide. Matchmaking, network development. We do a lot of market intelligence that we try to bring back to the sector, try to make a lot of connections. We also do program management for a number of the ministries. And then we also host events, strategic events, and try to facilitate collaboration, especially between our academic, our civil society, and our private sector members, to gain access to public funding opportunities. So that's very briefly what that is. Let's see. All right. There is a lot of animations in this slide. Okay, I'll work on that later. We define the problems that we have roughly into 3 different categories. You can either have too much of it, and you talk about flood management and everything that comes with that. You talk about there's not enough of it, and you can talk about why that is. So we can talk about droughts, or we can talk about deficient infrastructure, which of course is a nice plug into what we're discussing today. And then of course there's the quality of the water as well. I mean, too much of certain minerals or contaminations is not a good thing. So around these 3 topics, we have a lot of activities, and we try to generate a certain level of activity coupled with some advocacy to address these issues and create political support for some of the things, some of the messaging that we try to do. Let's see. So here's the next slide. I found a beautiful copyright-free photo of Chicago. So that's, personal victory for me. The Partners for Water program is really with which we use to serve the U.S. market and a number of focus areas within that market, mostly the coasts, East Coast, West Coast approach, and then we have also the Midwest approach, which is very much focused on the activities happening in and around Chicago and the network of the consulate in the Midwest. The program Partners for Water is set up to address water security and water safety issues in global urban deltas, knowledge exchange, but mostly with the US, it's the development of business-to-business relationship. Currently, we're working on resilience programming in a variety of East Coast states and cities, ranging from Boston all the way down to Miami. And we have coastal resilience activities and emergency preparedness, in which we operate very closely with the embassy in Washington, D.C. That's very much targeted right now to the states of Maryland and Virginia. Then we have Midwest, where we have our strategic conference, VEFTEC, every year. Unfortunately, not this year. It's been a little bit of a rough ride with COVID. I think we've all experienced that. So for us, the fact that we can still be visible and support the Chicago Water Week and everything that they stand for, I think is very important. And it's also a signal from us to say, hey, listen, we're still here, still available, still interested. So strategic partners and the co-collaborators that we have, of course, like I said, the Embassy of the Kingdom of the Netherlands in Washington, and then all of its consulates scattered over the US and Canada. In this case, our partners, Jeroen and James in Chicago. We have a variety of ministries at the national level, but also other authorities like a Flood Coalition, FEMA, and all of the various state chapters. Do resilience events with APA, with ASLA, of course, always looking at the Army Corps to see what they're doing, and the Chicago Water Association in this case, for which we are grateful that we have this opportunity to present here. Finally, the Dutch and the US private sector, that's where it happens, that's where the business is, and that's what we try to facilitate. So if you have questions, ask any of us, we'll be more than happy to help. And with that, I will try to not take up any more time. If I can get the slides moving, that'd be good. There you go. That's the last slide. I just wanted to point out, I already mentioned the COVID period. It has not been fun, and it has had a business impact, but it hasn't been all negative. We have found many of our companies and many of our collaborators to focus specifically on what COVID brings to the table and how we can turn a challenge into an opportunity. So this is a publication that is available through our site, the DutchWaterSector.com, about the various responses that have been made to the COVID-19 pandemic in terms of technological solutions. Not just NWP, a lot of the members from the Water Alliance are also in here. And with that, I'm going to give the word to my co-collaborator and colleague, Harro Brons from the Water Alliance. Harro, it's all yours.
Thank you very much, Arjan, for also doing this event together with the consulate. As mentioned, Harro Brons, I work for the Water Alliance as Business Development Manager. And I'll briefly go into our ecosystem here in the Netherlands, where the NWP is a broad water sector oriented organization. So also do, as we say, delta technology, so dikes and barriers, for example. Water Alliance and with the partners here, we are working solely on the water technology field within this ecosystem that I briefly wanted to touch base on. At 1 o'clock, we see the name WETSIS for scientific research. It's a scientific research institute where 65 PhDs with working for top European universities are working with about 100 companies on scientific breakthroughs in water technologies. If IP has been found, this can be taken up by either a multinational, a startup, or a medium-sized company and be taken up further to validate, scale up, for example, by doing testing in the applied research phase of such an ecosystem. In the end of that ecosystem round, there's Water Alliance, and we basically connect companies from either side, either size to the market. This can be customers, can be partners on the technology or on the commercial field, of course. So under that umbrella water campus, here we have the science at WETSIS, applied research at CEW, and the business to business at Water Alliance. We have about 110 Dutch members in water technology, and the themes are also matchmaking, business development, and as mentioned, very important, also a portal to the European market. It's always a give and take. There is a strong potential also in working together in developing technology. Next to embassies, consulates, where we were very happy to work to cooperate with, we have been active in the US for quite some time, especially also with US cluster water tech partners. So close by to Chicago, we have close ties with the Water Council in Milwaukee, the Cleveland Water Alliance, and also looking at working further with Current Water. GMA Blue Tech, also a cluster well developed, San Diego, California, where we have done projects with. Within the internationalization, we do also work within European programs that, well, in the end, of course, support the Dutch water technology sector. And an example of that, I would like to present to you today, and also, of course, reach out to connect with us to, well, become part of this program. It's called EU Tech Bridge. And in this program, we match innovative European small and medium-sized enterprises with North American-based end users who are looking for innovations in the water field and energy field. For that, we have quite an extensive matchmaking process that we facilitate as program partner. We work together with 6 other European clusters where we are the specialist in water. And I will not go through every step, but basically what it means, we reach out to North American partners. I will give some examples later. They define their innovation need, present that in a webinar, and European SMEs can apply. We do a selection. Do they have the right TRL level, technology readiness level? Do they have the capacity, the ability to work across the Atlantic in the US, or do they need a partner? And they are presented to the North American case owners, who then decide from that long list to make a short list to go into one-on-one meetings. First of all, virtually, digitally, and then later on also physically, once we are, of course, again allowed to travel into the US. And I guess it's important to mention that it's an end user focused process. The end user, the case owner, is in the driver's seat. And we ask for time, basically. We facilitate all around, but it's the end user who determines how far he wants to go with a innovative solution that is presented to him. So some examples are of missions we've done the last half year. It's New York City, US. So basically you see from the New York City innovation needs that were presented, you have about 42 applications brought forward, and they're in the process then of presenting to different New York City parties, and that to further select those that have a true business case or a true solution for the need at hand. Same with Los Angeles and East Coast. Boston, we're still in the process of going into further one-on-one meetings and selections. Some of those parties are also not that far away. Massachusetts Water Resources Authority, MWRA, but also the City of Vancouver, Canada. And we've recently done a session with the LA Bureau of Sanitation. On the energy field, Con Edison. So these are some of those parties who presented. And it can also be that they present running, for example, innovation programs that they have, and they're interested in to see a European initiative that supports their needs. So let's talk about cooperation. I would very much like to call out, of course, two people out there who are interested to learn more about this EU Tech Bridge process, either as a case owner or as a potential partner. I used to say a European SME typically will need an American partner to go into that American market, and I definitely see a win-win with innovative technology and a strong American partner to do possibly on both sides of the ocean the good things or interesting things together on water technology. So happy to talk more, but we do, of course, go into the let me say that the primary speakers and the primary interest for you today. I would like to introduce Simon Jagers of Somotics. Somotics is an industrial analytics company that helps clients prevent unplanned downtime, improve operational efficiency, and reduce energy waste of AC motors and pumps. Simon is on the World Class Maintenance Foundation board and a member of the Forbes Technology Council. Before Somotics, he held senior commercial positions at Dell, Oracle, and EMC. Simon, the floor is yours.
Yeah, and thanks for not mentioning the many failed startups before this. I learned a lot, so to speak. So I just wanted to start off with echoing something that Jeroen Beekman, the Deputy Consul, said at the start of this call. He mentioned the aging water infrastructure. And I think that's really what's being echoed as well, for instance, by the American Association of Civil Engineers. They're really sounding the alarm about the aging water infrastructure. And they say that we're at a point where there's a very real risk to communities across the US losing access to clean water and wastewater services. But they also share an optimistic message in that same report that was issued about a year ago. And in that same report where they had this warning, they also said, and let me read this to you, they said, investment in the nation's aging water infrastructure composed of drinking water, wastewater, and stormwater systems can spark a new era of job creation and economic growth while protecting public health and improving quality of life for families across the United States. So, there's this dual message. On the one hand, we have to act now to avert a disaster, but on the other hand, which is the positive side of things, these investments really are a catalyst for job creation, economic growth, and public health improvements. So within that framework, our company, Somotics, provides industrial analytic services for water and wastewater companies. And this essentially means that we analyze machine data to help our clients to become more reliable, more safe, and more sustainable. As mentioned, my name is Simon Jagers. I'm one of the founders of our company. And today I'd like to introduce our unique monitoring system for AC motors and rotating equipment, such as pumps, that is based on a unique principle called electrical signature analysis. So what it is and what it offers and why it offers unique benefits is what I'll introduce today. But also, let me also say that the situation described in the US is something that's very similar in Europe as well. It's by no means unique, what I mean. And at Somotics, we work with a variety of companies in Netherlands, in Belgium, in the UK, to help them indeed eliminate unplanned downtime and reduce energy waste, and ensure that maintenance and operations are executed in the most efficient way possible. And they too face an aging water infrastructure, rising cost of downtime. I think what we also observe is that there's an increasing skills gap today, certainly in the European sector, but I understand in the US as well, where you have an aging workforce, certainly in technicians, and with young people nowadays wanting to learn how to code an iPhone app and not learn a proper trade. The problem obviously is that iPhone apps do not fix broken pumps. So I suppose both in the US and in Europe, companies are turning towards Industry 4.0, what's it called in Europe, digital transformation in the US, really to deliver tools and services that address some of these problems. Rising cost of downtime, a retiring maintenance workforce, but also consider ambitious energy waste reduction goals and probably more flexible work processes. And that is why most of the clients are investing in monitoring solutions for their critical pumps, right? So on the one hand, to shift from a reactive and planned maintenance strategy to a more, proactive condition-based predictive or prescriptive maintenance strategy. And to do that, you typically have to install a condition monitoring system. Now, these monitoring systems are fairly similar to a large extent, right? They have basically three components. You have a set of sensors providing data. You have a set of analytics that turns that data into information. And then typically you want to present that information to the maintenance technicians or other stakeholders so they can act on it, right? And that is exactly what we provide. There's one big difference. The data in our system comes from an electrical signature analysis, from electrical signals, current and voltage. And this approach has a couple of key benefits. Number one is that you can monitor the condition, the performance, and the energy of those pumps from inside the motor control cabinet. Zero sensors are placed on the motor or on the pump. And this is obviously useful if you have, for instance, submerged pumps, for which it's very difficult to install sensors on that pump itself. I think the second benefit of this approach is that you simply detect more failures because electrical signature analysis detects electrical and mechanical failures. The other ones are typically focused on one of the two. So you detect more failures from inside the motor control cabinet. And I think the third benefit of this approach is that it gives you insights into the performance and the energy consumption of those pumps, which simply allows you or provides you with actual insights about, for instance, energy savings potential. So this ASUS system, this monitoring system for pumps, is something that we provide, and we do that as a plug-and-play system that contains all required components, meaning a set of sensors and data acquisition devices and cloud communication systems. They send data to the platform where we have a cloud-based analytics systems that turn that data into information, and then a dashboard or an API to provide that actual information to the stakeholders on the shop floor or in the management teams. And all of this is provided as a service, which essentially means that we will do the analytics for you. We will share the reports and meaningful insights as you need them. Now, the underlying technology is based on the principle that the electrical waveform has a lot of information about, again, the condition, performance, and energy consumption of those assets. And we typically are asked, how is it possible to detect a mechanical failure in an electrical signal? So I'd like to geek out for a moment and explain to you that, because that's a returning question. And the underlying principle is that when there is a mechanical failure, you typically observe a vibration, a lateral or torsional vibration. For instance, if your pump starts to cavitate, or if there's, for instance, bearing failures on your pump, then it will introduce a vibration, and that vibration will travel from the shaft of the pump through the coupling to the shaft of the motor. And at the motor, that vibration will disturb, if you will, the air gap between the static part and the rotating part of that motor. And when you disturb that air gap, you introduce a wrinkle on your sine wave. So by measuring those wrinkles and analyzing them, we can detect a mechanical failure, a mechanical manifestation of vibration in an electrical signal, in addition to all the other elements that are part of this system. So when you look at how this manifests on a day-to-day basis, how this is being used on a day-to-day basis, I consider it more of a virtual doctor for AC motors and pumps that has, to a large extent, three use cases. Right, so one of our clients, for instance, in the UK, has a lot of remote pump stations where they have submerged pumps. So right off the bat, the fact that you don't have to install sensors on that pump in the field is useful because these pumps are submerged. But they're also remote, and they have a 4-hour response time before fines kick in. So they need to be able to prevent failures, because many of these pumping stations are in remote locations that cannot be reached in 4 hours. And then you should optimize for that as well, right? So we install SEM4 on these remote locations, and rather than doing very regular rounds to check on the pumps, just to be able to prevent failures from happening by doing a lot of maintenance, what we now do is we monitor those pumps, and most types of failures will be flagged at least a couple of weeks, but certainly 3, 4, 5 months in advance. So rather than having to do a lot of traveling to pumps that are otherwise well, confirming that they're fine and will be for the next couple of months, we monitor them for them. When there is a failure, we will alert them. They'll also have access to their dashboard, which is essentially a lot more efficient way to prevent that downtime from happening, right? And you could think of that as a physician detecting early signs of a heart attack to make it a bit more dramatic, allowing them to prevent unplanned downtime. I think another way to use is really to look at how a pump is being used, how it's being operated on a day-to-day basis. So that means that you detect patterns in how that pump is being operated that are not a failure per se, but for which you know that if you continue that behavior, it will lead to failures down the line. An example would be a pump that stops every 5 minutes or so, right? That will mess with the motor, if you will, in a rather short time frame. So we're looking at patterns in the data that indicate use of that system that will lead to failures down the line. And another example would be, for instance, the real-time pump performance curve that tracks the work points of the pump relative to the best efficiency point by looking at the active power and the speed of the impeller. All of that information comes from the electrical waveform. Now, and the third element, and I think it's interesting to see that energy optimization, energy reduction is gaining more and more traction. And if you have electrical signals, what better way to provide insights there, right? So an example of that is that we provide in the dashboard energy savings potential. And just to give you an idea, looking at all the pumps that we monitor, a good rule of thumb is that on a centrifugal pump, you can save 30 to 45% of energy without compromising on flow or output, just purely based on the data that we have. And that's significant because for most water utilities, pumps will represent around 60, 70, 80% of energy use on a day-to-day basis. And with industrial assets using around 30% of global electricity, you can imagine that this technology, and we hope to be a big part of that, can really make a meaningful contribution to lowering energy across the world. So that's what I wanted to introduce today. From our request to the audience is we're looking for water and wastewater companies in the US that are interested in working with us. We've deployed on over 100 sites globally. We're really keen to do that in the US as well, particularly in the water sector. So if you're interested in learning more, I'd be pleased to schedule a follow-up and share ideas about how we can implement a project and really kickstart our follow up on our ambitions in the US water sector as well. Thank you very much.
Thank you very much, Simon. For a general a guy like me in this field, just a short question. For your online dashboard, is it necessary, absolutely necessary, to use the cloud? Is that?
Yeah, yes. We need a cloud connection. So I suppose, like all IoT companies, more and more calculations are pushed to the edge, which also facilitates, for instance, different ways of working where you can actually control the pump on the edge. But we do need at least some connection to the cloud. So for any water company interested in working with us, but that cannot facilitate cloud, unfortunately, at this moment, it is not available.
But knowing all the work, the hard work you have done, it is quite a professional and secure setup. So in that sense,
yeah, well, that's right. I mean, we're ISO certified. We've been checked by the top 5, the big 5 consultancy firms in various locations. We work with firms like BASF, ArcelorMittal. We take security serious, and we're happy to share how we do that exactly. So if you check us out, you'll really know what we're doing.
There's one question coming in, Simon, through the chat. How do you connect the sensors to the motors, pumps, to acquire the data? Any examples?
Yeah, well, we measure current and voltage. Current is clamp on CTs, and voltage, it depends a bit on the situation, but there are ways to connect it. Yeah.
Thank you very much. Thank you for your presentation. Inspiration. I also like the part of manifesting. I thought that was the mechanical failure. It's a nice wordplay. We go on to the next player. Thank you very much, speaker. Thank you very much, Simon, and we'll see you at the panel discussion.
Absolutely.
Thank you, Simon, for that. So with that, we go to Hall 24K and Dave Burroughs. I love working with Dave. We've done a couple of events now together. When I asked Dave to send me a bio, he sends me a long version and a short version. The long version is 6 lines and the short version is 4 lines. So I'm going to splurge and I'm going to give you the 6-line version. Here it comes. Dave Burroughs is Chief Technology Officer for Hall 24K Water. It's an AI company specializing in end-to-end data analytics and artificial intelligence machine learning solution for the water sector. 30 years of experience in creating artificial intelligence rich systems for blue chip clients globally and evangelizing upon the use of advanced data analytics within the industry. For the last 6 years, Dave has led the technology teams at Hall 24K, integrating big data and the latest AI/ML technology to power AI-rich operational solutions at city and country scale, alongside the data science team and colleagues at Hall 24K. Dave, the floor is all yours.
Thanks, Ian. Yeah, thanks for that. Yeah, I usually get the short version, so that's yeah. So let me tell you a little bit about Hall 24K. Then I'll move on to give you some examples of work that we're doing, and finally, we'll finish off with how we're bringing some of that work together to build solutions we can actually put on customer sites. So Hall 24K started out its life as a data intelligence laboratory where we were looking at AI and big data across many different industries, including water. And that was back in 2015, 2016 sort of period. And what we found was that in order to move away from just producing reports about AI and machine learning and developing systems that go on people's desks and therefore change how they work, we needed a different set of solutions. So we spent quite a while doing two things. One is building ourselves a tool set that will allow us to create systems like this rapidly, and also a data science team, which we drew on from the entire world, a population of people who are much smarter than me, bringing those guys into the fold to look at how we could start to model some of these infrastructure environments. And we were very successful, very much so in water, but also in things like transport and other built infrastructure. So in 2019, we decided to basically create a group of people within the business that were going to specialize on water infrastructure and water machine learning in general. We've also got a sister company, which I'll touch on. We're not going to talk about that today. We'll touch on because of the cross-fertilization that we're doing between the two parts. So our data science tools are built to allow our data scientists to work at city and country scale. So these are inherently big data problems. So we're talking about analyzing distribution networks, analyzing sewer networks at huge scale. And it's that ability to bring different pieces of information together and deal with data at this holistic view that is what really excites us and what makes me get up in the morning. Yeah. Let's look then at the sort of tools we're using. So what we can see here is the toolkit that we use. So as you can see, we've got two outputs from whatever we do. One output is R&D and consulting, and finding unseen relationships or previously known about relationships, but where we've not had the data to really exploit those relationships. And I'm going to give you some examples of that. The other part is having done that work and having found, for example, that in a sewer network, you don't have to understand the exact gradients on the pipe, on the sewer pipe. If you look at the network as a whole, you can get a profile for how any liquid, any fluid is flowing through those pipes without the hydrological measurements that are normally needed to model that. So by looking at things in the whole, you can start to get insights. And part of our solution is the ability to create the models and do the R&D and do the machine learning, and then take those models, put them into dashboards or mini applications that are easy to deploy and can sit on someone's desk and provide them with advice and recommendations. In other words, providing decision support to the control rooms. We do that using our own AI platform, which is Dimension in this picture here. But another significant part of what we do is integration as well. So, being able to integrate multiple systems and bring all that data together is a prerequisite for the sort of large-scale data processing that we need to do. So, let's have a look at some examples. And the first thing I'm going to talk about is that we're not restricted. We're going to focus here today on infrastructure and maintenance and management, but we're not restricted to that. Some of the early work we did was on surface water modeling. And this is not hydrological modeling. This is looking at how water flows and river levels and looking at rainfall without necessarily understanding the topology of the landscape we're dealing with. But again, machine learning systems can learn how the water's flowing without having to understand the hydrology. So that was a wake-up call for there's a different way to look at large-scale networks, be those river networks, sewer networks, distribution networks. We started seeing ways that we can use very big data to start to model those. So a lot of what we do is outside of infrastructure and maintenance, but a lot of what we do feeds into that. So let's talk about assets, asset management, segregation, and predictive maintenance. As we've just heard, and as I'm sure you're all aware, telemetry is now the lifeblood of maintenance. Most organizations, be that water or people outside with large-scale networks of any type, particularly electromechanical networks, they're looking at data as a way to get a real insight into what the current state of their asset base is. Be that, you know, the old pipe mechanism, the old pipe infrastructure that you've got, which is, you know, ceramic or metal or plastic or whatever that infrastructure is, or whether it's the electromechanical equipment such as pumps and water treatment plants, etc. All of these things can be looked at in terms of operational modes. And what we've started doing is looking at the way in which all the telemetry is coming into a central system, a central hub, and we can collect that information and keep it together. But we can then use that information to start working out what the status of a piece of equipment is. We've been using lots of tools and technologies, some of which are neural networks and the latest machine learning approaches, others are simple linear regression. But over time, because we're pulling data from lots of different places, we get a much more accurate measure of what the operational status of assets are. And also over time, we can see how so certain pipes will degrade in a certain way, given certain ambient conditions. We know that certain pumps, for example, will degrade and fail, go towards a failure over a period of time. And if we're able to accurately model those, and we can see here at the bottom, we've got various mechanisms for doing that. Here we're using neural networks and clustering, and the different colors of clusters of machines that are in different operational states. But we can monitor that over time and start to get a feel for the resilience, the longevity, and the preventive maintenance schedules required from the telemetry that's being pushed out. So with more and more telemetry, we can get more and more of an insight into how we can do predictive maintenance, and also combine that with the service maintenance data, usually held in some service management system like SAP or whatever, bring that in, bring the weather history in, and you start to get a very rich view of what is driving reliability within your particular infrastructure. That means we can move towards less maintenance interventions while still maintaining quality, and we can move at the very least to knowing what the status of equipment is, so we can understand the risk in a water treatment plant, the risk and relative benefits of replacing a pipe network. And it's that multivariate, it's that multiple telemetry input that gives us the level of accuracy. Now, some of what we look at, of course, is the environmental impact. So the amount of rainfall on a sewer network, the amount of turbidity and suspended solids on inlets to water treatment plants. These are all important factors. And again, it's another set of data that we can bring in to the forecasting routines to give us even more insight. So we can look at, do you need to do jar sampling quite as often as you currently do? We can look at how do you change the processes within the water treatment plant when you know you had rain yesterday, and we know it's a 24-hour lag from where the rain was to the water treatment plant. So we can start to bring in the environment into this, and also the other way around. Very often there's clues in the environment and the way that the water quality is affected throughout the year as to what the status or leak status or overspill status is of the infrastructure as well. So again, by bringing that information into the models, you get an incredibly rich model with incredible accuracy. Okay. And finally, before I move on to an example of something we've done that pulls all of this together, learning from other industries. as I said earlier, we have a sister company that looks at infrastructure, and we've also been involved in lots of AI projects, including things like satellite imagery recognition, LiDAR, CCTV monitoring, various things. Computer vision in general is becoming an increasingly useful mechanism. We've just finished some work, for example, looking at the use of CCTV at inlets, looking for blockages, literally using them like security cameras. But of course, there's little side things we can bring in as well. So, for example, if you've got a measurement stick in the water of that inlet, we can start to use OCR against that CCTV image to give you virtual sensors. We're looking at work we've done in drone-based detection of damage to aeroplanes, and applying that to drone-based detection of damage within treatment plants, especially after storms over the natural events. So lots of things that we can draw on for other industries that are ready and there and waiting, and are therefore very fast to deploy within the water industry. Let me just go back one. So how do we bring all of this together? All of this R&D and all of this talk of big data and complex algorithms is all well and good, but unless you can put it onto someone's desk, it's going to have no effect. So one of the things we believe in is that we bring all the outputs from all the models, and we bring all the data into single combined dashboards. First of all, that allows you to remove data silos, because in doing the data ingestion for the analytics, you've got the data there ready to be used for just general business intelligence as well. But if we can feed that information into models and take the output from the models, we're no longer just getting simple SCADA alarms that say out of tolerance. We're getting alerts that say things like, there seems to be a blockage in this part of the network. There seems to be a problem with chemical stock levels in this clean water treatment plant. And we can start to interpret that raw data and build dashboards that make recommendations, rather than give you a tsunami of alerts that you inevitably turn off just to stop it beeping, or at least flashing on the screen. So if we can draw on all this telemetry that's coming in, and we can build models that more accurately characterize what's happening within your infrastructure, and can look at the degradation, the risk that you're carrying by a certain maintenance routine, the same models can be used to have more accurate, less intrusive, less false positive alerting mechanisms as well. And that's something we do in a product set that we call situational awareness. And that can be, in this example here is water treatment plant, but it can be distribution networks, it can be sewer networks. But using AI models as part of a standard dashboard puts it on the desk and gives the recommendations to someone who's got the knowledge to actually act upon them. So hopefully that gives you, in a short session, an introduction to the sort of work we're doing. We're currently doing research and development in multiple countries. We're currently part of a large research and development team that are looking at water quality management, for example, in both Singapore and Belgium. But it's how we can bring this, as I say, into applications and put it on desktops that's the key thing for us. And that's what I'd like to leave you with. HAL 24K are excited about collaborating with water companies and utilities in general, but specifically in the US. How can we work together to draw more information from that new tsunami of telemetry data that you're getting and start to put decision support onto your desks? With that, I'll leave it and take any questions.
Very nice, Dave. Thank you very much for that presentation. We're talking a lot about data silos, right? About sort of separated data sets. I mean, to me, as a sort of an outsider, I'm not a data scientist, not into the technology per se, but it seemed obvious to me that you would bring in as much data as you possibly can being a water company and being interested in, economies of scales in terms of efficiency and everything that you can accomplish that way. So what's holding the companies back then? What are the challenges that they're dealing with in integrating all that data into a whole set?
Yeah, I mean, there's many challenges that we see out there in the market, and different parts of the world have different at different stages along the journey. The Netherlands, in particular, of course, I would say this, are really quite far advanced in this. But the ability to bring data from multiple systems to one place is a challenge that everybody's facing, especially now with so much telemetry. It's such a big problem, and we were finding in the early days, back in 2016, 2017, we just couldn't get the data from the systems. Things are getting much better now, but it's still not perfect. So part of what we do and part of the tool set that we deploy with projects like this actually allows us, using almost drag and drop technology, to bring data from multiple systems into one place. And in a lot of occasions, we're working with companies, and it's the first time that's ever happened. So they end up with benefits far outside of the projects we're involved with, but the fact that we've brought that data together for them into an easy to access analytics database is a major benefit. But yeah, we've had to solve that problem ourselves, because a lot of companies are not in the situation where that combined data set is easily available.
Okay. Very good, thank you. It's actually a question from the audience that just came in. Frank Myers is asking, are your models also applicable in the world of Earth observation for agriculture?
Funnily enough, yes. We're actually, one of my colleagues, I think, who's on the call, I'll not ask him to join in, but please get in touch with us, because we're definitely looking at agriculture as well, both in terms of things such as surface water detection. Of course, that's important, but also, how crops grow and what the mixture of land usage is. Now, that's something that's a crossover into the water industry with things like water retention and water resilience mechanisms, and we're looking at the work for that reason, but we're also exploiting similar satellite type imagery for agriculture as well, and also drones.
Very nice. Okay, excellent. I'm going to leave it at that, Dave, for now. We'll see you back in the panel after this last presentation, and thank you, and keep up the good work.
Cheers.
Thank you very much, Dave. We slowly move on to our next speaker, and I would like to introduce Rudy Dijkstra to you. He's CEO of Acquaint and founder. Rudy actually has worked as project manager in the field of design, construction, inspection, and maintenance of pipeline systems, where he gained his pipeline asset management skills and knowledge. And back in 2012, it actually started as an example of that ecosystem we talked about. It started at a program at WETSUS with was called Smart Water Grids, which then led to the founding of Acquaint. Now we're 2021, and Rudy, we're quite curious to hear where you stand and what you can offer. So please, the floor is yours.
Thanks a lot, Harold, for the introduction. I think I have the controls already. Let me check. Yeah, get acquainted and experiencing better insights. I will explain more about that during my presentation. So Acquaint actually was founded 7 years ago. So recently we had our 7-year anniversary. And still, I think we matter in some sense. So we heard a lot about pumps already. I think we heard a lot about data science and making good predictions. And I think we heard a lot already as well about aging infrastructure. And what is interesting is that the American Waterworks Association addresses a renewal and replacement of these aging assets as their priority number one. What's also interesting is that 60% of all the fresh water that is being produced is leaking through leaky pipes. It also has to do something with aging infrastructure and also the integrity of these kind of systems. And it all brings us to like having a future-proof and sustainable water supply. And I think this problem is not only in within the US, but it's also across all the Western countries at this moment. In our ideal world, no pipe will ever fail again due to aging. In our world as well, the utilities know exactly what the condition is and when to do what basically and where. So having a good short and long-term asset planning in terms of maintenance, renewal and replacement. So I'll address later on during the presentation how we will be able to do that. So coming back to the problem, I think I already mentioned aging assets. What happens as well is that almost 50% of all the pipes that are being replaced nowadays, they find that these pipes are still in a good quality or good condition, and they shouldn't have been replaced actually. And it all has to do something with the accuracy of the models that are used nowadays. So the theoretical models more or less don't line up with the real life situation. And there's an increased need of having reliable data to make better decisions. It's also when you have like a large asset base, it becomes more hard to determine where should they start first. For instance, if you have 1,000 kilometers of line which are typically all of the same sort of age and materials, so where at which location should they start? So these are typical problems that are being addressed by us. What we also learned from the past years that over 98% of all the lines that have been inspected were still in a good quality condition. So this means that we are able to give our clients, the utilities, the power to focus on the less than 2% instead of replacing all the lines. And that's quite a significant efficiency step to take. What's also interesting is that if you have a look into like how risk management is being performed nowadays with using like bow tie analysis and determining the probability of failure and the consequence of failure, that a lot of utilities are focusing on the reactive side. That means that they focus on installing like DMAs and doing leak detection, for instance. For us in particular, we like to focus here on the left side of the bow tie here. So our goal and objective is to get control of the aging aspect, to exactly to be able to determine when a pipeline is likely to fill. And that's quite difficult with a large range of different kind of materials, but I think we do a fine job there. So that's also our biggest differentiator compared to other technologies available these days in the condition assessment world. So the solutions that we provide are related to three different kind of technologies. Basically, the main technology is similar within the Aquarius and the pipe skinner. So the Aquarius is typically used for risky pipes where you'd like to have a higher rate of security. So it covers like the quality of the pipe itself and the joints. So it's basically a full condition assessment, knowing the condition of every millimeter of pipe. It's a tool that is being propelled with water pressure through the line, so it's typically in use for transmission mains or pressurized drinking water mains. And it's really flexible. You can bend it over your knees, and it's really easy to push it through. The other tool is that we use is the pipe skinner. So actually, at this moment, there's one in use in the southwest of the US, taking measurements. And what it does, it's an external scanner, so it collects data on the outside of the pipe. It's a do-it-yourself application. So we equip like mechanics or service providers with these kind of tools to collect data with every opportunity. So since there's a shortage of having reliable data to improve like decision making, we developed a tool that can collect data basically at every opportunity that is out there. So you save the cost of really digging up a pipe specific for doing an inspection. But if there's a lot of opportunities out there these days, so that you will be able to collect data on the go. So once you have all the data, this kind of data, it's absolute, so it's really reliable. So the data can also be used for making better or improved prediction models. So we combine this kind of data with like the soil properties, the groundwater levels, etc., to determine like the degradation rate. What happens as well is, like, for instance, if we do like one inspection, the inspection data is also used for like other pipelines with similar circumstances, as an example. So basically, there's no limit to length or diameter of when you apply these kind of tools. So let me go over to the next slide. So when it comes to the key differentiators, I think first of all, simplicity is one of the most important things. So almost everybody can use it. So I even asked my kids to trial the equipment once, in this case the pipe scanner, and it worked out pretty well, so to say. The other thing is that the tools have a wide range of application. This means that a lot of the materials that are typically used in these kind of mains can be inspected with one kind of application. The other thing is that it's the only technology available nowadays that can really determine the remaining life of these kind of crucial assets. And I think the fourth benefit is, you're collecting reliable data for improved data science capabilities. I think that's quite an important step as well. So it's that was more or less my presentation. So I'm open for some questions. So thanks a lot.
Thank you very much, Rudy. Yeah, I saw your pipe scanner is already, as you mentioned, active in the US. Is, for example, the Aquarius, the technology ready to be implemented in the US straight away?
Yeah, the technology is ready to be implemented. So we're training the first service providers now in the US. So it's open for usage, so to say. So it can be used. Yeah.
And therefore you are interested with that service provider to, of course, come into contact with utilities. Are you also looking at contractors who do pipe replacement, or what is your focus for the US?
Yeah, for a focus for the US, our main objective is to get connected with the utilities itself. So to get a good understanding on how decision making works within that utility, and how we can make sure that our data, or the data that is being gathered with these kind of tools, have the highest leverage, so to say, for the utility. So basically, it's that easy to train people to use it. So basically, we're not related to one service provider. The other thing is that obviously for like doing renewal or replacement or relining of pipes, it has quite an advantage there as well for locating the weaker spots to do some maintenance. So, but our priority is within the utilities itself.
Clear. Yeah. So also there, thank you for your presentation. I see there's no questions coming into the chat, but we're looking forward possibly to connect to some of the people in the audience with our panel discussion. So, Arjen, if you agree with me, I would like to ask everybody to join.
At least the speakers, Harro.
At least the speakers, yes. No, and I would be happy to have somebody from the audience join, Arjen. I'll have a few questions for them as well.
Yeah, and if there's a question from the audience, we can actually give them the floor because we're in a nice compact group. So that's possible now. So we can consider that. Maybe, Harro, before we go into the panel discussion, I think we need to sort of, address the elephant in our small panel room here, and this the fact that we have established a fantastic panel with absolutely no female representation. That's certainly not our intention. And gender equality, social inclusion are topics that for NWP, Water Alliance, and all the speakers are important. So let that at least be said, rather than it being said behind our backs that we're not trying hard enough. We are trying. In this case, I found out actually that Dave's finance director, so she's the one who determines that Dave actually gets to be here. So that's a woman. So that's at least a plus. So let's get started, Hado. You want to kick us off?
Yes, I might have actually throw a question in our audience, and it's a generic one, but we hear quite a bit of talk, of course, on the Biden administration. But I'm a little bit curious if we talk about infrastructure and the future of infrastructure, what needs to be done, in how dependent utilities are, regions are on large federal infrastructure spending packages. And maybe somebody can, give us some input on how that looks. I don't know if we have any utilities on board who could share their views on that. Or, for example, if I continue a bit, as some of those key drivers on the things that we talked today, I think it's driven by water quality issues. There's more strict approach in the US now to that water quality driven measures. Costs, I think all speakers today do have a cost optimization. I think that could be an interesting one for our panel, actually. Of course, there is an investment, but there's something to be taken out, but for the utility, for the water sector, through each of the technologies that we see today. Simon, maybe I can give you the floor on that, because I do recall that some of the pilots you've done or projects you've done in the UK, the customer already paid back his investment in quite a short time, just on energy. And so it was not his primary goal, but the energy savings that he gained already paid back his investment with you guys.
Absolutely. Yeah, we should do this more often, by the way, Harlo. So thanks for that great introduction. No, that's a fair statement. I think, by and large, I really believe that technology should remove trade-offs, right? Where in the past you would say, I can make something good, I can make something cheap, and I can make something fast. Pick two. And I think today it's around good quality, sustainability, and a proper price. Pick three. I think that is how I look at technology, as really an enabler to remove those trade-offs. And then when you look at where we come from, we started in the maintenance space, focusing on preventing unplanned downtime. But given the data that we collect, current and voltage, and the fact that you can collect or you gain an insight into both the physical performance as well as the electrical energy to generate that physical performance, you gain a lot of insights that allow you to reduce energy waste as well, where it's more around providing the data or the information that enables clients to make data-driven decisions about energy savings projects. And one thing I see on a day-to-day basis is that on the shop floor, reliability is key, right? The maintenance engineers, they are really focused on keeping the pumps running. And the other half, in the boardroom, I think the focus is really on sustainability as well, where the first primary action is to reduce the energy per liter of drinking water. So by combining the two, I think that's one example of how technology today really is used to remove those trade-offs. You can both facilitate a highly reliable network and also with that same technology ensure that energy waste is limited or greatly reduced.
And in extent to that, what we experience as well is that within data we're talking about silos, but like operational cost and capital cost is really something as well that still is a bit in silos, so to say. So for instance, if we do an inspection, we know that almost 95% of all of replacement costs could be basically prevented from doing this kind of replacement. So there's a huge cost saving involved, but nevertheless you have to do like some operational expenses, and it saves you on the capital cost side. But Sometimes very hard to combine both actually within like making a decent business case. So I think it's something that you experience as well, Simon. So.
Yeah, certainly. But I know, Dave, at Hall 24K, you know, we used to say data is a bit like love, right? If you share it safely, it's more valuable for all involved. And I think that's really where you guys come into play, right? Using data, extracting as much value as possible.
Yeah, absolutely. And as you guys have just been saying, it's about taking data from different places and different sources. For example, we have a lot of experience on degradation curves, and it's not always true that the infrastructure that's most degraded needs fixing first. You know, you've got to have factored into those equations and those prioritization decisions, what is the incremental benefit of whatever the repair strategy is. So if you want to dig the roads up and replace all the pipes, then yeah, great. You'll get fantastic, a much better quality distribution network or waste network, but it's bang per buck. So you've got to factor in, okay, if I do minor repair, at what point is it more profitable, more beneficial to start digging those pipes up? And again, with data, you can start to answer some of those questions without having to assume linear degradation curves. There's clues in the data as to what those degradation curves really look like, and it'll be different in different parts of your network. So absolutely, data it's a very rich and very important resource. And although we're getting, some would say, too much of it from telemetry these days, there's gold in them there data hills.
But Dave, following up on that then, I mean, obviously when we talk about data, that's all around in terms of the different data sets, but the actual data that you need to get, to justify the investment in the technologies that you guys provide, are those data sets currently available in the US market? I mean, do the utilities or do the water companies have access to those data, and will they share that with you?
It's difficult for me to comment on the US, but certainly elsewhere in the world, it really is a mixture. You'll very often find that the cost of treatments, whatever those treatments and repairs are, is well known, but the potential, the lost opportunity and potential loss of quality of service is more difficult to get. So it's usually a mixture, to be honest, Arian. And very often, yeah, you're going to have to say, okay, we need to make these following assumptions. We can then, by doing data collection, prove whether or not those assumptions turn out to be true. But yeah, I think it was Rudy that said, it is difficult sometimes to get that accounting data, actually look at the real costs of maintenance and actually look at the real benefits and the reduction in reactive maintenance after replacements and repairs. It's a difficult problem. The data is not always there, but you can start collecting it now.
Yeah, it all comes down to having like a decent asset management approach, right? So without a decent plan, it's very hard to collect the right data at the right time, and yeah, and making like good risk profiles of your assets. It's quite hard when you don't have any data available. So
yeah, yeah, but at the very least, you can start taking impact into account. So the distribution network, what's the demographics and populations that you're serving? There are factors you can pull in, but as I said earlier, you then need that big data capability to start balancing those equations. The good news is, the technology is out there now, guys. It's there. It's available. We're using it. And if anybody on the call wants to talk about degradation planning, we do a lot of work on transport degradation, for example, and we find a lot of those algorithms are coming over into water.
And maybe, Dave, following up on something you just said there, it is out there today, right? But I think that what I find is that some people underestimate really how fast developments are going. And I think, you know, when you look at innovation, it follows a to some extent predictable pattern, right? You have mutations, you have selection, and then retention.
Very Darwinian.
Well, it is a universal pattern. It's called universal Darwinism, indeed. But when you look at specifically at digital innovation, then the physical constraints are removed, right? I mean, it's if you want to invent a new pipe, you have to go into material science. You have to build that pipe. You have to put it under pressure. That's a lot of work to test a new material for piping. But if you can do that digitally, that's really fast, right? So what you're seeing is that, and this is echoed by Peter Diamandis, his 6D framework says that as soon as a technology is digital, it hops on this Moore's law, where it doubles in capacity and halves in price every 18 months or so. And then it starts deceptively small. But at some point, looking at, for instance, the camera, that 0.1 megapixel becomes 3.2 in 4 or 5 generations. And then your technology is better than the analog alternative with all the benefits of digital technologies. So when it then comes to what you're saying, Dave, is start working with it. I think you're absolutely right, because things are accelerating. And it's also about learning to work with data, making sure that the people working with that data get a hang of it, because ultimately tools and technology will not solve it all. I think it's really important to get this culture right, to make sure that you implement tools that help us to work better, safer, and smarter, that complement human creativity rather than trying to replace it. And that's an interesting field to be in.
Yeah, absolutely.
Actually, we have an opportunity. Actually, let's see if we can bring James into the group here. James has a good question with regards to sort of the applicability of the data to the scale that you're trying to accomplish. James, how are you?
Doing very well. But yeah, I mean, I think my question coming out of what you guys have been talking about is, how do these use cases differ for utilities of varying sizes? Like you have these behemoths like MWRD in Chicago, or the Department of Water Management in Chicago, versus sort of a mid-sized city's water utility, or like a small town utility in Minnesota. Like, can they all make use of these equally, or do the use cases look different? Or I mean, what extent is there need to be like a level of capacity to make use of these smart solutions?
I'll let Rudolf Simon go first.
Rudy?
Yeah, well, in our case, size doesn't matter in this, so to say. So,
Offering thought, thanks.
Yeah, for us, like the data that we collect is really powerful for making these degradation patterns, so to say. So, it all depends on what are the circumstances for us, and if there are like unknown circumstances, then size does matter sometimes. So, but basically for us, size is not really an issue. So if you have, for instance, we're doing a project now for a Belgian utility. They only inspected like I think it's like 20 miles or so, and that data is being used for like there's 600 kilometers of pipeline to do a good quality risk assessment on the probability of failure and the consequence of failure. So it depends very much on the different kind of situations that you have, like for instance, different kind of soil characteristics or different kind of materials used. So that influences the basically what we do. But yeah, basically it's applicable for also the small scale utilities. They very much rely much more on having like these bulk transport lines coming to their towns, right? So it's maybe even more risky if you don't have like any backup lines available. So
I mean, certainly in a bigger organization, at the end of the day, is going to get bigger benefits, but the costs aren't quite as linear in terms of scale for deployment of advanced systems these days. The price of neural network technology and GPUs and everything else are all coming down. And one thing we do find is that the smaller companies are the ones that are often more agile. They're more able to go with the concept of let's just try something for 3 weeks and see what's in the data. So that they're very often more willing to experiment compared to larger organizations who, of course, have just bigger organizations, just more politics, etc. But you can very often get a small organization running quickly with something. Therefore, their deployment costs are incredibly small. So even though their benefits aren't huge, they can generate enough benefit to justify the project. Of course, the bigger boys can take longer because they get more benefit at the end of it. So it really is horses for courses. Yes, both can benefit, but they benefit in different ways. In one way, it's their ability to add, in a very agile manner, adopt new technology, and in another way, it's the volume that allows them to get true benefit.
We have a question in the chat, if I may give that to you guys, from James Schipma. Sometimes it seems we are spending all our time reacting to aging infrastructure, and we do not get a chance to be proactive. Do you have any suggestions on how to balance the two and get to a point where you can plan for the future?
Jane is here, huh? So we just beat her to it. So hi, Jane, thank you for your question.
Thank you. Hi.
So what do you think, gentlemen? Who wants to take a first stab at that one?
I will try. Or Simon?
Right, Rudy.
Yeah, I think for us in our case, so I showed you the bow tie that is quite typically used. So for the preventive side, I think like technologies that we're using are quite typically applied in combination with leverage of using like data science and prediction modeling. But in the end, I think you need both. So you also need the right side, like DMAs, doing pressure monitoring, and use it basically as an early warning system. And I think once you have like control of the level of risk that you are having as a utility, I think then you're also able to determine like plans for the future. What kind of maintenance do I need to do? When should I do replacements and where? You can even make cost estimates for doing it and make a budget. So I think basically you need both. And I think the comparison that you can use for that is like, I think in our opinion, the development of our autopilot should be there, and where both are combined in one single application. So we aim for that to develop that in the near future, but in the end, it will be something like that. So having control on future investments, what's happening today, on what risk should I work on today or tomorrow or next week or within a few months. But it's all about having control. I think risk management is quite an important thing on having that settled. So that's more or less my opinion. So.
Well, maybe to add to that, I'm a board member at the World Class Maintenance Foundation in Netherlands, which focuses on innovation in maintenance. And I think one of the things we're addressing as a foundation is that maintenance is not a sexy profession, is the proper expression, I suppose. And that's a real shame. It is regarded as a cost center in many ways. And I think that needs to change. And I think that needs to change at the board level. The problem, I think, is that when you are expecting or considering maintenance as an afterthought, you'll see that in the budgets, you'll see that in how these functions are being sort of promoted and so on and so forth. Whereas you should see the response if maintenance doesn't do a good job. So I think there's lots of technologies that allow you to do both. You could say, if you get the basics right, you can then start to think of innovation. But I think one of the key things that should certainly be an element in any future planning is to address the fact that in many ways, in many companies and in many geographies, because this is all over the world, maintenance simply doesn't receive the recognition it deserves. And don't let an accident happen. Don't wait for that to happen, because there's so much value being created. And I think that's perhaps one thing that the maintenance community should do themselves, really, is to help management understand better what the value of maintenance is. So it's a two-sided thing, but I certainly wanted to mention that as something that we're working on in the Netherlands. Make maintenance sexy again.
Well, my only input here, the guys, I agree with the guys. Yeah, we call it the Cinderella service, Simon. It's always the part with the least capex. But one of the key things I think that's happening now, and again, I'm sorry to do this, but it is data. One of the issues we come across all the time is if you're over maintaining, actually knowing what status your equipment's in is difficult, because before you get to anywhere near a failure, you've replaced it. So how do you do that? And believe me, there'll be clues in the data. So the data will start to tell you about, are you sure that you're not over maintaining this one? And that sort of insight, it's not going to be linear, it's not going to degrade in a linear fashion, but there'll be clues in the data. And just like the car industry, where now the car tells you it requires a visit to the dealer because the oil's a bit sludgy, looking for the same clues and doing that, preventative, predictive style maintenance, I think is something that may well help change the balance of reactive and proactive.
Can we give a few words to Jane maybe to respond on all that input?
I had to find my unmute, sorry. Yeah, I think that's all. I completely agree. Because I'm more on the maintenance side, so I'm trying to connect the two, so for sure. Yeah, I think everything you guys said was super important, and I like having that perspective because I spent some time in Denmark too, so I kind of can see both sides of that, and the difference in involving the maintenance more as an interaction with maybe higher level people, that there's still that connection versus the total separate departments and separation between those two. So I think task force and stuff like that, because sometimes it is harder with a larger organization to have everyone involved at every moment. But if there's task force or groups that can come together and interact once a month or something, I think it's important. Mm-hmm. For sure. I also like no matter how much technology we have, it's getting the people all involved with it. So what Simon said before is definitely important, I think. And I think sometimes you can spend a bunch of money on all new equipment, but if it could just sit there and if it's not really being used the proper way, or it's only being used to half of its potential or something like that too, that's really important.
Thank you.
Thank you.
Simon did also give us, I think, the slogan for the next webinar on this topic, and make maintenance sexy again. So everybody, please look out now. So we'd be happy to get your feedback. I think we're slowly going to a close. I think we could talk more. So if there's ideas to do this again, please let us do so. Arjen, can I give you also? Thank you for doing this together with James and the Consulate and the Chicago Water Week.
Same here, Haro. It's been a fun experience. I actually think we gave Rudy the informal cue to actually get out of here. I'm not sure if that was supposed to happen. Hold on, let's see if we can bring Rudy back. No, this is good, and I think also we acknowledge Stefan and Ivana in the background, feeding us with information, helping us putting it all together. I mean, Haro, you and I get to be on camera, this one time. I think, we probably should not make like a regular thing of that and just let the experts do the talking. But I think so far it's been a very friendly session. I mean, we've all been very nice to each other, and we've given each other the floor, and we haven't really, we haven't had any drama yet. So let's see if we can create a little bit of drama, because I'm looking at this from the outside and I see that you guys are more or less serving the same clients, the same potential customer market. Are you guys friends? Are you collaborators? Are you arch nemesis? Are you sworn enemies? Something in between? What are you?
No, I think I like where you're taking this, but I think you're talking to the wrong crowd because we really serve different markets. I know Hell24K is really, really good at what they do. So I'm happy they're not competing with us because that would be a mighty competitor. And I know that within our space electrical signature analysis, that there's only one company that can claim the Olympic gold medal, and that's us. So we really are world champions at what we do, and I know the same for Hell24K. So I would like to, you know, we need to fight over something else.
Rudy, any suggestions? Is something you want to fight about before we close off the session?
Where's the spec break between the pump and the pipeline?
Yeah. You're essential as well. Yeah.
Dave, any last words from your side?
No, I don't say anything that might upset someone now. But no, I'm sure there's, yeah, first of all, there's plenty of things to do in the marketplace. And to be honest, we very often get involved and work with people like the guys on the call because, you know, it's a skill sharing thing. There's skills we can find on both sides to help each other, I'm sure.
Yeah.
Very nice, gentlemen. I think with that, you know, on behalf of Water Alliance, Netherlands Waters Partnership, and the Consulate of the Netherlands in Chicago, I would like to thank our speakers. I would give you a hand, like, you know, a round of applause, but it's virtual, so it doesn't really resonate as well as it should. But thank you for your time. I agree with Haro. I think there's a basis for doing this again. Yeah, everybody have a fantastic weekend. Be safe, be healthy, and we'll see each other hopefully out there live again soon someday. And for all of the people in the audience, all of our contact details are on that last slide. We'll leave that up there for a few minutes so you guys can take your screenshots or do your old-fashioned pen and paper copy downs. So,
and I guess we will reach out as well. Arjan had two people present in the audience. Thanks for joining today. Fully agreed.
Thanks,
Thank
everybody.
you.
Thank you. Bye-bye.
Thank you.